Example 1 says determine the relation for the set of ordered pairs -2, 3, 0, -4, 1, 2, and 1, 5 is the relation or its inverse of function. So here we have the given set. I'm just going to rewrite it here. To determine the inverse, all we have to do is interchange the x and y coordinates, because we know that the domain of the original relation ends up being the range of the inverse, and the range of the original ends up being the domain of the inverse. So I'm going to label this original, and now for the inverse, interchanging the x and y coordinates, I get the points 3, 2, -4, 0, 2, 1, and 5, 1. Now let's answer the second part of the question. Is the relation or its inverse a function? Well, we know that this one is a relation because the x-coordinate repeats. So for an x-coordinate of 1, there's 2 possible answers. So this is not a function. What about the inverse? All the x-coordinates in the inverse are different. And so for this reason, every x-coordinate will have just one corresponding y-coordinate. So the inverse will be a function. Therefore, the inverse is a function. Example 2, use the graph of the function below to obtain the graph of the inverse. The graph of the inverse will also be a line, so I just need to choose 2 points from the original line and then interchange the x and y coordinates. Make sure you're choosing points that are easy to read off the graph and are accurate. I'm going to choose this point here. The grid lines intersect at -4, 4, and this point here where the grid lines intersect at 0, -3. So these are my 2 points in the original function, -4, 4, and 0, -3. And then to find the points on inverse, I'm going to interchange the x and y coordinates to give me the new points 4, -4, and -3, 0. And I'm going to plot these new points now. And I'm going to draw a new line to represent the inverse. So this right here is my inverse, and this was the original. Example 3, find the inverse of the function defined by f at x is equal to -5x plus 2. So first replace f at x with y. Then swap or interchange x and y. And then isolate y by following BEDMAS or the order of operations backwards. So addition has to be reversed first. So instead of adding 2, we're going to subtract 2 from both sides, giving us x minus 2 equal to -5y. And then we're going to divide both sides by -5. So I'm going to divide each term here by -5. And then the final equation for the inverse using function notation. And we get f inverse at x is equal to -1/5x plus 2/5. Let's look at the last example here. It says for g at x is equal to 4x plus 8, determine g inverse at 16 minus g at 1. So first we have to determine the inverse function. So replace g at x with y like we did in the previous example. Then swap your variables and isolate y. We're going to subtract 8 from both sides first. And then we're going to divide both sides by 4. So the inverse function would be 1/4 x minus 2. Now I'm going to evaluate g inverse at 16 using this function that I just found. That means I have to replace x with 16 wherever I see it in the function there. of 16 minus 2 would give me 2 as my answer. I'm also going to evaluate the original function at 1 here. Which will give me an answer of 12. And then subtracting those two values, would give me an answer of negative 10. Okay, now the last example, example 5. It says a simple rule to convert from Celsius to Fahrenheit is double the Celsius temperature and add 30. It says use function notation to write an equation for this rule. Call the function f and let x represent the temperature in degrees Celsius. So I'm going to call f at x, where x is the temperature in degrees Celsius. And what do I have to do to that temperature? I'm going to double it. So I'm going to write it as 2 times x, and then I'm going to add 30. So part A is done. Now part B, it says determine the inverse. So I'm going to replace f at x with a y. I'm going to interchange x and y. I'm going to get y by itself by first subtracting 30 from both sides. And then I'm going to divide both sides by 2. And my inverse function be 1/2 x minus 15. So that means if I want to take the Fahrenheit temperature and convert it to Celsius, I take half of it and subtract 15. Okay? So part C says one day the temperature was 14 degrees Celsius. Use function notation to express the temperature in degrees Fahrenheit. So I have to use my original function, which relates the Celsius temperature to the Fahrenheit temperature. So I'm going to sub in 14 for x. And at a temperature of 14 degrees Celsius, we would end up with 54 degrees Fahrenheit. And last part here, it says another day the temperature was 70 degrees Fahrenheit. Use function notation to express this temperature in degrees Celsius. So in this case, I want to find the Celsius temperature from the Fahrenheit, so I have to use the inverse function. And I'm going to sub in 70. So I have to take half of 70 and subtract 15. And that would give me a temperature of 20 degrees Celsius. And so 70 degrees Fahrenheit is 20 degrees Celsius.